Hi, welcome to my channel. In this video, you're going to learn about simplifying radical expressions by applying the laws of radicals. Now, let's have a review about the different laws of radicals. I actually have a video of the different laws of radicals, the derivation of the laws. You can watch it here. I'm going to include the link in the description below. Now, here, let's have a short review about this. So here, if I have the nth root of a raised to n, that is equal to a if n is odd number. So here, the index and the exponent is the same. Odd means 3, 5, 7, 9. Simply, the answer is equal to a, this one. But if I have the nth root of a raised to n, and n is even number, and a is negative, this is negative, you need to get the absolute value of a. Simply, getting the absolute value is just removing the sign. Now, if we have a product here, the nth root of the product of AB, that is equal to the nth root of A times the nth root of B. It means you're just going to separate. And here, quotient. So, you can separate also the numerator and the denominator. That is the nth root of A divided by the nth root of B. And here, look at this one. We have a double radicals here. So it means the mth root of the nth root of A. So you can find or you can simplify that by multiplying this m times n. That would be the index, whatever the result or the product. And that is here. Instead of getting first the nth root of the inner, then after that get the mth root of the last here. So you can do it like this, multiplying. Okay, so all of this, we're going to apply this in the given exercises that we're going to answer, or the radical expressions that we're going to simplify. So let's simplify the following radical expressions by applying the laws of radicals. So I'm going to place it here, the first law of radical, that is the nth root of a raised to n, that is equal to a if n is odd. But if n is even, you need to get the absolute value of a. So now here, what is the square root of 25? It means, what is that number if we are going to raise to 2? The answer is 25 because we know that the index here, if it's square root, the index is 2. Or what number that if you're going to multiply 2 times indicates the index, is equal to 25. So that is 5, right? So therefore, in exponential form, 25 is equal to 5 squared. So that's the first step, rewrite in exponential form. Now, understood the index here is 2, so we can now apply this law of radical, which means the answer is equal to 5. Now here, if we have the square root of negative 8 squared, simply, that is the absolute value of negative 8, and that is equal to 8. Now, what about here? Square root of 48. We know that 48 is not a perfect square. So we can rewrite 48 as a factors of two numbers wherein one is a perfect square. Why perfect square? Because the index here is 2. But if you have hard time thinking about it, you can also use prime factorization. Let's say 48 is 6 times 8, if that's what you remember. And then 6, we know that 6 is 2 times 3. And then here, 8 is 4 times 2. Okay? Now, you can stop right there, or you can continue doing up to the end wherein all the ends here are prime numbers. So now we have 2, and 2, that is a perfect square. Another 2, and 2, another perfect square. Which means that here, 2 times 2, 4 times 2, 8 times 2, 16. And for sure, 16 is a perfect square because they are in pair in here. Now, it means that we can rewrite 68 as 16 times 3. Okay, so 16 times 3. And we now know that 16 can be written as in exponential form as 4 squared. Therefore, since the index here is also 2, we can simplify that as 4. The square root of 16 is 4. So we can bring that outside the radical sign. And what is left inside the radical sign now is 3, because 3 is not a perfect square. So the final answer is 4 times the square root of 3. Now, what about number 4 here? We have the cube root of 7 cubed. Okay, the index and the exponent is the same. Therefore, the answer is simply 7. Now, what about for the cube root of 125? So, 125, here the index is 3. Can you think of a number that if you are going to raise to 3, the answer is 25? You try 5 because it's divisible by 5. 5 times 5, that is 25. 25 times 5, that is 125. So it means that is 5 cubed. So 125 in exponential form is 5 cubed. So now the index here and the exponent is the same. Therefore, the answer is equal to 5. Next, 81. Square root of 81. Okay, what number raised to 2? The answer is 81. So we can write this as 81 as 9 squared. Okay, now what about x to the 6th power and y to the 3rd power? Now, in this case, you can rewrite, because the index here is 2, you can rewrite this as a factors of what? You can write this as x squared times x squared times x squared. Why? Because 2 plus 2 plus 2, that is equal to 6. So you can simplify. The same, the index and the exponent now is the same. And y is, this is y cubed. So you can write that as y squared times y. Understood there is 1 here. So if you are going to add this, 2 plus 1, that is 3. So now, we can rewrite it like that. 9 squared times x squared, x squared, x squared times y squared times y. So now we can apply this law, number 1. Simply, we know that the index here is 2, right? Because it's square root. So we can now get here, what is the square root of 9 squared? The same index. The answer is A. So the answer is 9. So that one is 9. Now, for x squared, again, the same index and exponent. Therefore, just copy the base. So that is x. Same thing with the other one, x. The other one is also x. And for y, that is y. And the last one, that is y raised to exponent here is 1. That would be remain inside the radical sign because it's not a perfect square. Now, I can write this in exponential form as x cubed. So that is 9 x cubed y times the square root of y. That's the final answer. Okay, let's have number 7. So here 16. So what number raised to 4, the answer is 16. So we know that 2 times 2 is 4, times 2 is 8, times 2 is 16. So the answer is 2. 2 to the 4th power is equal to 16. So now, I can rewrite this as 2 to the 4th power. What about x to the 5th power? Since this is 4, I can simply write the x to the 5th power as equal to the x to the 4th, because I need the same exponent as the index, times x. That is equal to x to the 5th power because we are going to simply add the exponent here. That is 4 plus 1, that is equal to 5. Now, what about y to the 8th power? Well, I can write that as y to the 4th times y to the 4th because the index is 4, so I'll make sure that my exponent here is 4. Okay, so that is equal to 8. 4 plus 4. Multiplying, we add the exponent, so 8. So therefore, I can rewrite this as 2 to the 4th, x to the 4th times x, and y to the 4th times y to the 4th. The index here is 4. Now, you can simplify. Applying this law now, the index and the exponent is the same, therefore the answer is 2. So that is equal to 2. The 4th root of x to the 4th is x. For x, that we cannot simplify that, so start now with, or proceed now to the y to the 4th, and that is y. Another y to the 4th, and that is y. Then inside the radical sign now is x, 4th root of x. Now, I can simplify this, or I can write in exponential form, y times y, that is y squared. So the final answer now is 2x y squared times the 4th root of x. So that's how you're going to simplify radical expressions by applying the laws of radicals. Now, I have second part of simplifying radicals. You can watch it here. I'm going to put the link below in the description. And please don't forget to subscribe to my channel, share my videos, and like if you like it. Bye! See you in the next one, and thank you for watching.